If the concentration of sulfite ions is 300 centimeters cubed of sodium sulfite, well, let's just double check that we know what sodium sulfite is. SO3 is the sulfite ion, and sodium sulfite has a valency of 2, while sodium only has a valency of 1. So it's Na2SO3, and I'm given the concentration of sulfite ions. Now, if I were to take a look at the ratio of sodium to sulfite, it's a 1:1 ratio, which means that if I have got 0,3 moles per cubic decimeter of sulfite, I have also got 0,3 moles per cubic decimeter of sodium sulfite. So they now would like to know the mass. So I've got the concentration, and I'm able to say number of moles is equal to concentration times volume, which is 0,3, which is the concentration that they gave me, multiplied by the volume, which is 0,3 decimeters cubed, and I get 0,09 moles of sodium sulfite. However, that's not the question. The question asked me for the mass, even though that is written over there. The question asked me for the mass, so I now need to say mass is equal to number of moles times molar mass of sodium sulfite. So it's 0,09 multiplied by the molar mass of sodium sulfite, and that's going to be 23 plus 23 plus 32 plus 16 plus 16 plus 16, and it comes out to be 126. And the mass that I get is then 11,34 grams. They then say what volume of water needs to be added to reduce the sulfite ions to such and such a concentration. Now, remember, I've told you that the best way of doing this is to put your rectangles in. I have a solution of 0,3 molar or moles per cubic decimeter. That's the concentration. My volume that they've told me about is 0,3 decimeters cubed. How many moles do I have in that? I have 0,09 moles. I've calculated that over there already. And I'm going to take that same number of moles across to a new container, and this time I need to get to a concentration of 0,01 moles per cubic decimeter. So what is the volume? The volume is going to be equal to the number of moles divided by the concentration, which is 0,09 divided by 0,01. And that turns out to be 9 decimeters cubed. But that's the full volume. I already had 0,3 decimeters cubed in over here, so I have to subtract it from there to see what water I'm going to add. So 9 minus 0,3 is going to be equal to 8,7 decimeters cubed that I need to add to this solution over here in order to dilute it from being a 0,3 molar solution into being a 0,01 molar solution. I've got a certain amount of oxalic acid, and they dissolved in a certain amount of water. So number of moles is equal to 19,24 divided by the molar mass. And the molar mass of oxalic acid is 126. I go 12 plus 16 plus 16 plus 1 plus 1 plus 1 plus 0 plus 16 multiplied by 2 multiplied by 2. And when I get that all out, I'm going to land up with 126. That gives me 0,15 moles. And they tell me that this is made up to a concentration. The volume is going to be 200 centimeters cubed. So I say concentration is number of moles divided by volume. 0,15 divided by 0,2. Remember, you have to divide by 1,000 to get it into decimeters cubed. And you get 0,76 moles per cubic decimeter. Now they say what number of moles of solute transferred to a second flask with the aid of 25 centimeter cube pipette. So in other words, if I had this, they're looking for number of moles. I have got a concentration of a certain solution, and I have a volume. So I'm going to go 0,76 multiplied by 0,025. I need to take that 25 and divide it by 1,000, and I get 0,019 moles, which is as close as anything to 0.02 moles, and that is the number of moles that was transferred. Now, if this was in another container, I could then go forward to ask further questions about what concentration, how much water to be added, etc.